that the period is equal to 1 over the frequency. So if you know how many vibrations per second that you've got, if you say 1 and divide it by that, that will give you the period. The next one says frequency equals to 1 over the period. So if you know the period of a pendulum and you want to know its frequency, you take 1 and divide it by that value. The third one is T over T prime equals the square root of L over L prime. Well, you used this one in the lab the other day. It says that if you know a period and a length here, and you know either a new period or a new length here, you can solve for whatever you don't know. Just 1 second. And then the final one is that the period of a pendulum is equal to 2 pi times the square root of the pendulum's length divided by gravity at that point. That's what that one's referring to. Yes?
Were you saying it was 1 over, the first and second one is 1 over, what is it?
Yeah, T equals 1 over F and F equals 1 over T. You're welcome. All right, so looking at problem number 2, or number 1, you've got .25. Again, it's got to be in terms of centimeters. I mean meters, I'm sorry. I was wrong. And you've got a length of 0.1. And we're going to set that equal to the square root of, it's the square root of this over the square root of that. I may pass this class next year. I don't think I'm going to quite make it this year. Almost did. Alright, the period of the one that goes with this is 1.1 seconds. So this is my new period that I'm solving for here, okay? And I just wrote it in reverse order from what's on the board. Now, anytime you're solving ratios, or not ratios, but fractions together, you could take this and multiply it by this, and then divide it by whatever it was you were going to be multiplying by your variable. Okay?
Say that again.
You could take the two numbers that you're multiplying together, and then divide by whichever one you were going to be multiplying by the variable. So here I'd have the square root. Is this showing up? Is it dark enough?
It's a little light.
It's a little light? Okay. Let me try this real quick. It's going to take a second for it to catch up. But the other day I had people saying it showed up pretty well when I did the light off. Is that better? Okay. Can everybody see that all right?
Yes.
Okay. And I'm actually going to put it on the screen like this. It tends to only want to show up if I slant it, yeah.
Because of the light.
Yes.
Well, I don't know if it's because of the light or not. Because even when I don't have the light on, it does better like that. All right, so what did I say? I've covered up what I was writing. It was the square root of 0.25 times what?
Well, that's times the variable. It's going to be 1.1 times the square root of 0.1.
Oh, it was 1.1 times the square root of 0.1. Okay.
So you increase them?
Yeah. And then I'm going to divide that out by the square root of 0.25. And I get 0.6957. So 0.6597, if we go to 2 sig fig, would be what? 0.70, yeah. Go ahead, Darian. I crisscross this here, and then divide it by that. Y'all done law of signs yet in trig?
Yeah.
Yes.
It's the same principle there. If you're solving for what's in the denominator, you multiply those two values together and then divide by the other.
Okay.
Everybody groovy? All right. Yes. Sure. Sure. Just give me a percentage of the proceeds. For homework, I want y'all to do 2, 3, and 4. Believe it or not, we're going to do something else. We're not going to have quite an hour off.
I'm asking,
What now?
which ones?
2, 3, and 4 right underneath that problem number 1. Those are your problems dealing with pendulums on that worksheet. That right there.
This one.
What I outlined in blue. Alright? That is the homework.